Am I audible to all of you? Just write in the chat box. Okay. So I am sharing my today's presentation slide. So in the last class, we already studied the stack in queues. So we already discussed it. The memory stack, how it is how it is functioning. It's two operations: the push and the pop, and the applications of stacks. Then queues, the different types of queues, the applications of queues. It's different types like circular queue, priority queue, doubly ended queue, and lastly we already discussed the difference between stacks and queues. So all of you understand the topic of stacks and queues? Just write in the chat box. Okay. So now we are moving to the last topic of unit 1, which is subroutines. So it, this is the last topic of unit 1. So basically a subroutine is a set of instructions which are used repeatedly in a program that can be referred to as subroutine. Remember the word, it is used repeatedly. So only one copy of this instruction is stored in the memory. In order to save memory, only one copy of subroutines are stored in memory, but these instructions are basically used repeatedly in the program. That's why it is called as subroutines. So when a subroutine is required, it can be called many times during the execution of a particular program. So a call subroutine instruction calls the subroutine. So, but care should be taken while returning a subroutine, as subroutine can be called from a different place from the memory. So, care must be taken in returning the subroutine, as it can be called from anywhere from the memory. The content of the program counter must be saved by the call subroutine instruction to make the correct return of to the calling program. So these are some of the important points related to the subroutine. So let us discuss it in detail in the next slide. So as you can see from the diagram that in a program, if you are executing an instruction and before the next instruction you need to call, if there is a requirement to call a subroutine, then a subroutine is called after an instruction, and then the subroutine do perform its work, and after its execution it returns back to the next instruction of the program. You can clearly see from the diagram as shown in the slides. So subroutine linkage method is a way in which computer call and return the subroutine. So this is the method. You call a subroutine, then the subroutine perform its work, and after execution its work, it returns to the next instruction. So the simplest way of subroutine linkage is saving the return address in a specified location. So such as register which can be called as link register. So this type of register which is used for subroutine linkage is known as the link register called subroutine. So this register name is link register. All of you understand it? Can we proceed further? Just write in the chat box. Okay. So moving to the next slide. Now an important concept is there in the subroutine, which is known as subroutine nesting. So subroutine nesting is a common programming practice in which one subroutine calls another subroutine. As you can see from the diagram, that subroutine 1 calls subroutine 2, then subroutine 2 calls subroutine 3. So this concept is called as subroutine nesting. So as you can see from the diagram that a linked register is here, and in the linked register it returns the address of subroutine 1. So this is the concept of subroutine. So in the next slide we will discuss this concept in more detail. As you can see from the diagram, subroutine 1 calls subroutine 2, calls subroutine 3. So from the below figure, assume that when subroutine 1 calls subroutine 2, the return address of subroutine 2 should be saved somewhere. So if linked register stores return address of subroutine 1, this will be destroyed or overwritten by the return address of subroutine 2. As you can see, this is the stack memory. So first the subroutine one execute, after that subroutine 1 calls subroutine 2, and lastly subroutine 3 is called from the subroutine 2. So in the stack memory the return address of one subroutine 1 is present, after that the return address of subroutine 2 is present, and finally the return address of subroutine 3 is present, just in the reverse order, because basically the stack follows the last in first out property. So as the stack data structure is used, so lastly comes the subroutine 3, but its address is at the top of the stack memory, as we already discussed the stack data structure. So this is the concept of subroutine nesting. So all of you understand it? Can we proceed further? Just write in the chat box. Okay. Now the next topic is advantages of subroutines. So there are many advantages of using subroutines. So first is it is used in decomposing the complex programming task into simpler steps. So this is one of the two main tools of structured programming along with data structure. So basically it is used to decompose a complex program into simpler steps. So the second advantage is reducing duplicate code within a program. As we already know that a subroutine is stored in the memory only once, so it reduces the duplicate code within the program. The third advantage is enabling reuse of code across multiple programs, because same code as the same subroutine has been used in multiple programs, so it uses the concept of reusability of code. uh, the fourth advantage is dividing a large program task among various programmers or various stages of a project. So in that case also subroutine is used. And the last advantage is hiding implementation details from users of the subroutine. So these are some of the major advantages of using the subroutine. So in the next slide, we will discuss some of the disadvantages of subroutine. So there are some disadvantages of subroutine as well. So first disadvantage is compared to using inline code, invoking the subroutine imposes some computational overhead in the call mechanism. As you see from the diagram that in a program one instruction is executed, and if it requires a subroutine, then before executing the next instruction it needs to go to the subroutine, and uh, if the subroutine is taking much more time, then your program execution time will be much more. because the execution of subroutine also takes some time. And the second disadvantage is a subroutine typically requires standard code both at the entry to and exit from the function. So basically, the subroutine requires standard code. So the standard code is required for making the subroutine. So these are some of the two disadvantages of using subroutines. So that is all for the subroutines, and this concludes the unit one. All of you understand the topic? Just write in the chat box. Okay, so this concludes the unit one, and we will going to start the next unit, which is unit four. We are not taking the unit 2 and 3 because those units are not important. The other important units are unit 4 and unit 5. So we are going to start unit 4, and in your midterm, unit 1 and unit 4 are going to be there in your midterm, and your midterm is going to start in the September. After 15 September, I think your midterm will going to be start, and in your midterm, unit 1 and unit 4 will be there. So I am sharing the slides of unit 4. Just a minute. All of you see the slides on your screen clearly. Just write in the chat box. Okay. So all the recorded lectures except today's lecture are already in the college YouTube channel. You can also refer the recording of Unit 1 lectures from the college YouTube channel. So let's start Unit 4. So the Unit 4 is basically of memory organization is the name of the unit, and basically it deals with the memory hierarchy. So memory hierarchy is the basic of memory organization. So basically in a computer system design, memory hierarchy is an enhancement to organize the memory such that it can minimize the access time. So the memory hierarchy was developed based on a program behavior known as locality of references. So this is the major factor on which memory hierarchy is built. It is known as locality of references. So basically the memory hierarchy design is divided into two main types. So first is external memory or secondary memory, and the second is internal memory or primary memory. So the secondary memory or external memory, these devices are accessible by the processor through input-output modules. As they are not directly accessible by the processor, that's why they are called as external memory. But in the case of internal memory or primary memory, these devices are directly accessible by the processor. So that's why they are called as internal memory, as they are directly accessible by the processor. So this is the introduction to the memory hierarchy. Let's discuss it in detail in the next slide. So as you can see from the diagram, it is much more clear to you that the memory hierarchy is divided in various levels, from level 0 to level 4. And as you can see in the diagram that at level 0 position CPU register is there, in level 1 cache memory is there, level 2 main memory is there, level 3 magnetic disk, and the level 4 consists of optical disk and magnetic tapes. So these are the levels of memory. That's why and you can see that they are placed in the form of a pyramid. So as you move up, uh, at the left hand side you will see that from bottom to up, as you move from bottom to the top, the increase in cost per bit is increases. So whatever you store in the register, that is the most costlier one. So it is the most costliest register, is the most costliest. And from this arrow you can see that as you move from top to bottom, the increase in capacity and access time is there. So basically in register you get very less time, but in the magnetic tape you have you the access time is uh, very large. So these are the characteristics or the memory hierarchy. You can see that the memory hierarchy is in the form of the pyramid, and it it is from the level 0 to level 1, and these levels are fixed. uh, so at level 0 CPU registers are there, so you can remember it thoroughly, that at level 0 CPU registers are there. In the same way at level 1 cache memory, and level 2 main memory, and so on. So these levels are fixed. So moving to the next slide. So next topic is characteristics of main memory of memory hierarchy design. So there are some characteristics of memory hierarchy. So first is capacity. So remember the previous slide diagram. It is a global volume of information the memory can store. So as we move from top to bottom in the hierarchy, the capacity increases. So the register is having the smallest memory, and the magnetic tape is having the highest capacity. So so the important characteristics is capacity. Now the second characteristic is access time. So it is the time interval between the read write request and the availability of data. So this is the definition of access time. So as we move from top to bottom in the hierarchy, the access time increases. So the smallest access time is required by the register, and in the same way, the largest access time is required from the magnetic tape. So these are the two important characteristics: capacity and the access time. Now moving to the next slide. So the other important characteristics of memory hierarchy are performance and cost per bit. So in the case of performance, so earlier when the computer system was designed without memory hierarchy design, the speed gap increases between the CPU registers and the main memory due to large differences in access time. This results in lower performance of the system. Thus, enhancement was required. So this was done earlier when the memory hierarchy design was not considered. The performance of the system is not very good, but this enhancement was made in the form of memory hierarchy design, because of which the performance of the system increases. But as it is as we are using the memory hierarchy design as shown in the diagram in the previous slide, so it increases the performance of the system. So the last characteristic is cost per bit. As we move from bottom to top in the hierarchy, the cost per bit increases. So basically internal memory is costlier than the external memory. So the cost per bit is highest in the case of registers, which is at the level 0. It is having the highest cost. So these are the four important characteristics for designing the memory hierarchy. All of you understand it? Just write in the chat box so that we can move further. Okay. So moving to the next slide. So let us discuss each of the levels of the memory hierarchy in detail. So at level 0, registers are present which are contained inside the CPU. So that's why they are called as the part of the internal memory. So since they are present inside the CPU, they have less access time because all the execution of the program are done inside the CPU. And since registers are present inside the CPU, so they have taken less access time. They are most expensive and therefore smallest in size. That is, the register size is basically in KBs. So registers are implemented using flip-flop. As you already know, the flip-flop, you already studied it in the digital electronics. So the registers are basically implemented using flip-flops. So basically the level 0 consists of registers, and registers are contained inside the CPU. So moving to the next slide. At level 1, cache memory is present. So it stores the segments of program that are frequently accessed by the processor. So this is very important. The code which is frequently accessed. So this is very much important in using the cache memory. So that code of the program which can be used frequently is stored in the cache memory. Not all the code is stored in the cache memory, but frequently accessed code or the frequently required code is going to be stored in cache memory. So it is expensive and therefore small in size, and the size of cache memory is in MB, means megabyte. So cache memory is implemented using static RAM. So as the flip flops are implemented, as the registers are implemented using flip flops, so cache memory is implemented using static RAM. Or RAM means random access memory. So this is cache memory which is present at level 1. Now moving to the next slide, level 2. So at level 2, main memory is present. So it can communicate directly with the CPU and with auxiliary memory devices through an input output processor. So it is less expensive than the cache memory and therefore large in size. So basically the size of the main memory is in few GBs. GBs mean gigabytes. So main memory is implemented using dynamic RAM. As the cache memories are implemented using static RAM, but the main memory is implemented using the dynamic RAM. So main memory is present at level 2. So you need to remember it thoroughly that at level 0, CPU registers are there. At level 1, cache memory is there. At level 2, main memory is there. Now moving to the next slide. Level 3. So at level 3, secondary storage devices like magnetic disk are present. So they are used as backup storage. They are cheaper than the main memory and therefore much larger in size. In few TBs, TB means terabytes. So basically, the magnetic disk is having larger than the main memory, but it is much more cheaper than the main memory. So when you required to save the data in TBs, we need magnetic disk, which is present at level 3. Now moving to the next slide, level 4. So at level 4, tertiary storage devices like optical disc and magnetic tape are present. So they are used to store removable files, which are of very large sizes. So they are the cheapest and largest in size. So uh, its size ranges from 1 to 20 terabytes. So basically, it is having a very large size, but it is very much cheapest in terms of cost. So these are the four levels which we already discussed uh, diagrammatically in the previous slides. So all of you understand it. Just write in the chat box so that we can move further. Okay. So there are there are some important observations. So the following observation can be made when going down in the memory hierarchy, means from top to bottom. So cost per bit decreases, as you know that the cost is highest in the case of registers, because as we remember the diagram, it is of the pyramid shape, and here at level 0 registers are there. So, and at the last, magnetic tape is there, which is at level 4. So we are discussing these points in terms of from going from top to bottom. So the cost per bit decreases. So basically, the the costliest uh, memory is level 0, which consists of registers, and it is decreasing from top to bottom. The second point is frequency of access decreases. It means the access time. The frequency of access decreases. The third is frequency of access means the register is having the we can store very few instructions in the registers, and most of the data is stored in the magnetic tape, which is at the level 4. So frequency of access decreases. The third is capacity increases. So capacity is as we moving from top to bottom. So the capacity is at the highest in the level 4 and smallest in the level 0. So it is increases from top to bottom. The last point is access time increases. So the register is having the smallest access time, and the memory and level 4 magnetic tape is having the largest access time. So access time increases. So these are the important observation in terms of when we are moving from top to bottom in the memory hierarchy. So you need to remember these points thoroughly. So moving to the next slide. So what are the goals of memory hierarchy? So the goals of memory hierarchy are to obtain the highest possible average access speed. This is the first goal of memory hierarchy, and the second is to minimize the total cost of the entire memory system. So these are the two important goals of memory hierarchy. So first is the highest possible average access speed, and the second is to minimize the total access cost of the entire memory system. So these are the important goals of memory hierarchy. All of you understand it? Just write in the chat box. Okay. So that's it for today's class, because your next class will going to be start at 3 o'clock, and uh, we we just completed the memory hierarchy, the topic of unit 4. So just remember that in your midterm exam, unit 1 and unit 4 is in your syllabus for the first midterm exam, which will be conducted after September 15. So thank you very much. We will going to start a new topic on Saturday. So now you can leave this meeting.